Okay, here's the second example. And we're going to get all the way to the standard deviation, so we want little sigma, little baby sigma. So remember your formula, expected value of x squared minus the expected value of x, and that quantity squared, that's going to give you the variance, and then you have to take the square root of variance. That will give you standard deviation. So we're going to go through that whole thing. We have a density function. Oops. We have a density function. This example is in terms of y. Just to sass it up, I guess. Make it exciting. 1/8 y plus 1. This one is defined between 2 and 4. And it's 0 elsewhere. That's y plus 1. It looks like a 7, but that's a 1. I gotta stop being so messy. Okay, so let's get cracking. I'm going to do it in order. So I'm going to do the expected value of y squared first. So I'm going to go ahead and take the 1/8 out. There's my little integrand. I'm going from 2 to 4 because those are our boundaries. And this one, I'm going to do the first one, y squared times y plus 1. So that gives me y cubed plus y squared as my little thing that I got going on there, which is y to the 4th over 4 plus y cubed over 3. And then I have to multiply both of those times 1/8. So I get y to the 4th over 32 plus y cubed over 24. And let's go ahead and plug in our values there. Y to the 4th over 32 plus y cubed over 24. We're plugging in 4 and 2. So when I plug in 4, I get 256 over 32 plus 64 over 24. When I plug in 2, I get 16. And then I get 8 over 24. I'm going to go ahead and combine the 32 ones first. I'm going to do those two together. 256 minus 16 is 240 over 32. All right, now I'm going to do the 16 and the 8. Don't forget you're distributing that little negative right there. So that gives me 56 over 24. Reducing those fractions. The first one, I can take, looks like 16 out of both of them. So I get 15 halves. This one, if I take an 8 out of both of them, what is that, 7/3? Okay, that makes it easier for me to see. Common denominator is going to be 6. So I have 45 6 plus 14 sixths. Wait, that's not right. Is that right? 45 6? So I got 59 6. Yeah, that's right. I have. There we go, 59 6. Okay, I've got to remember that number because that's just this first little fraction right here. I'm not fraction, but that's the first part of the formula. So I have that number right there that I'm going to plug into the formula. Now I need to go after this number. So I'm going to do that now. I got to scoot everybody up. It's this one giant shift. And let's do the next set in green. So this time I've just got to do the expected value of y. So it's just y times y plus 1. Same boundaries, same all that other stuff. So I've got, that gives me y squared plus y when I distribute that little y there. What? My cat is doing weird things. What are you doing? What are you doing? Give me that. Sharks to sit on calculus. Alright. So y cubed over 3 plus y squared over 2. And then I got to apply my little 1/8. So I have y cubed over 24 plus y squared over 16. Now we're going to apply our boundaries of 4 and 2. 64 over 24 plus 16 over 16. That's the first one. Then when I plug in 2, I get 8 over 24 plus 4 over 16. So again, if I collect those little 24s first, 64 minus 8, let's see, I'm going to scoot over there where I have room. 64 minus 8, I got 56 over 24 for that one. And then I have 16 over 16 minus 4, gives me 12 over 16. Then I've got all kinds of goofy reducing. Again, looks like 8 is my common factor here, so that's 7/3. This one, if I take out a 4, I get 3/4. And then my common denominator is going to be 12. So I have 28 twelfths plus, looks like 9 twelfths. gives me 37/12. So that's expected value of x. Now remember, you're supposed to square that quantity. So I have to do 37/12 and square it. So, what's 37 squared? Ooh, my calculator. Oh, here we go. I should probably pause the video so that it has a nice flow, but that wouldn't really be our style. 1369 over 144. That's my second expression. Okay, so I have my first expression is up here, 59.6. So that's what I plug in first. And I have to subtract that with this 1369 over 144. Okay, now who thinks I'm still going to remember those two fractions when I scoot everybody up? Not me. Alright, well I think I could still see them there. Okay, 59.6, that's expected value of x squared. And then the expected value of x, and that quantity squared is that fraction. Common denominator is going to be 144. So I have to do 59 times 24. Oops, over 144. Minus 1369 over 144. So that gives me 47 over 144. That's your variance. If I want to get all the way to standard deviation, you have to take the square root of that. So the square root of 47 over 144. It's not pretty. I mean, really, it's the square root of 47 over 12. I guess we'll go ahead and convert this one to a decimal now that we're at the very end. So you're probably like, why didn't you do that before we had to do all those stupid fractions? Fractions are good. They make you pure. 47 divided by 144. So we get 0.57. That's your standard deviation. That's it.